The first lesson will be on matter and radiation, chapter 1 of the AQA A-level Physics specification. The first thing to consider when discussing matter and radiation is atomic structure. The structure of an atom is as follows: a central positively charged dense nucleus, which is composed of protons or neutrons, the collective term for protons or neutrons being nucleons. Surrounding this positively charged nucleus are shells or energy levels of negatively charged particles known as electrons. Some properties of these particles which can be compared are their masses and charges. The charges will be measured in the SI base unit coulomb, the masses will be measured in the SI base unit kilogram. The charge of the proton and the electron are plus minus 1.6 times 10 to the minus 19 coulombs respectively, and the neutron is neutral, so has a charge of 0. Comparing them relative to the charge of the proton, a proton has a charge of plus 1 with an electron having a charge of minus 1, the neutron's charge is unchanged, remaining at 0. Their masses in kilograms: the proton and neutron have a similar mass to 2 decimal places of 1.67 times 10 to the minus 27 kilograms. The electron has about 1/2000th of this mass, giving us approximately 9.11 times 10 to the minus 31 kilograms. Since our protons and electrons have equal but opposite charge, it implies that if we have the same number of protons as we do electrons, we're going to end up with an uncharged atom overall, an atom with a charge of 0. Now that we've discussed atomic structure, the next thing to discuss is isotopes. The definition of an isotope is an atom with the same number of protons but a different number of neutrons. Say, as an example, we took some arbitrary element on the periodic table X, where X can represent any of the elements. Each of those elements on the periodic table has a number to its bottom left and a number to its top left. The number to its bottom left, which I'm representing with the variable Z, represents the proton number, the number of protons in a normal atom of that element, where A represents the nucleon number, i.e. the sum of the number of protons and the number of neutrons. Because the masses of the protons and the neutrons are so much larger than the masses of those of the electrons, the nucleon number is sometimes also referred to as the mass number. Since each isotope can have a different number of neutrons in its nucleus, we represent the type of the nucleus as a nuclide. We next want to discuss the idea of specific charge. In physics, the word specific means per unit mass or divided by the mass. In the case of specific charge, it means take the charge of our particle and divide it through by the mass of that particle. Since we know that charge is measured in coulombs and mass in kilograms, it tells us that specific charge, which is coulombs divided by kilograms, must have units of coulombs per kilogram. Let's take the example of a neutral hydrogen atom, one which has a singular proton for its nucleus, no neutrons, and an electron. From the table that we looked at before, we know the charges and the masses of the proton and the electron respectively, and can therefore calculate their specific charge values. The specific charge of a proton is 9.58 times 10 to the 7 coulombs per kilogram, which you get by dividing its charge by its mass. Using the same process for the electron specific charge, we find it has a specific charge of 1.76 times 10 to the 11 coulombs per kilogram. That was the first part of matter and radiation. Hope you enjoyed.